This problem involved the concept of a potential energy well. Potential energy is always found with respect to another height. Normally the height is the ground, which has a height equal to 0. In this problem we will see that the ground level of the house equals our 0 height, and that when an object is in the basement, the potential energy with respect to the ground is negative. This tells us that in order to move the object upward, energy will have to be added to the system. Here is our house with the included heights. The mass of the hammer is 1.5 kilograms, and the hammer is represented by the gray box. To find the potential energy of the hammer in the attic with respect to the ground level, we will use this formula. You can see the box has a higher potential energy when it is in the attic than when it is on the ground. We plug in our values and find the difference in potential energy between the attic and the ground. Next we want to find the potential energy difference between the ground and the basement. It is easy to see that the hammer is at a lower potential in the basement. We substitute in our values and find the potential energy of the basement with respect to the ground to be negative. In part B, we want to find the change in potential when the hammer is brought from the attic to the basement. We know that the potential energy will be less in the basement than in the attic. The basement, Y1, is the final position, and the attic, Y2, is the initial position. We substitute in our values and find the decrease in potential energy between the attic and the basement.